Hey, what's up? I'm Austin Griffith, and I just want to do a quick screencast about predictive deployment. I've made like this quick script, and I just want to demo like a very simple use case first. We're gonna fire up Ganache. So we have a blockchain running. This is the predictive deployment repo of mine. I'll link it up probably right underneath this video. You clone it down, you CD into it, you have to install ethers.js, then you do a Clevis create simple if you're using Clevis, but whatever, you can come up with whatever you need to create this smart contract. You just need to get the contract created and compiled into an ABI and bytecode. So I'm going to do that now. Basically, all this contract does is it has a constructor, and within the constructor we emit some global variables and whatever the argument was that was passed into it. It's just kind of like a fake contract to show how this predictive deployment stuff, in particular this predictive deployment script that I've basically put together from the work of George and Alex. So let's see, that should be compiled. Let's see, that bytecode is put together. The ABI is right here. Very simple stuff. But what we're going to do is we're going to pass all of that in. There's that. You can just copy and paste this right from the repo. We've compiled it. Okay, so then we're going to get into this counterfactual repo. So counterfactual is like the name of it right now, but I like predictive deployment better, but that probably doesn't describe all the different use cases, so maybe it's going to remain counterfactual. But anyways, then we're going to run the script. Let's look at the script real quick again, just to see it. In particular, like giving props to LimeChain because they did all the work here. I just put it into, I took their work and put it into like one cohesive file, and I added the 4 cows. Let me find them here. Beef, right. So I added these 4 cows here, so you can tell right away when you see one of these counterfactual transactions that it's arbitrary and therefore like not crafted specifically. It just lets you know that like there's no way someone has the private key for this. Okay, so this is all explained in the article that you're probably reading here. So let's just jump into it and actually run it. So what we need to do is call this craft function so we call craft, but we pass in the ABI, or it's a path to where the ABI file is, a path to where the bytecode is, and then some gas constraints. Basically, the gas limit we're going to put on it is 150K, and I think it's 1 gig away there. And then this is just the argument that I pass in. So the last thing is all the arguments that'll go in. This will be the sum argument that goes into the contract. So what we're doing is we're creating a transaction that will eventually deploy this contract with 99999 as the arguments. And this thing is going to give us back, and I'm piping it to JQ, which just processes JSON and makes it look pretty. This gives us back this transaction. So if we push this transaction on chain, it's actually going to create this contract for us, but we don't have to do that now, right? That's the counterfactual side of it. It's like, if we need to do this, we can put it on chain, but we don't have to. So this will be the from address. This will be the account that actually deploys the contract, and this will be where the account lands. So let's say you actually do need to do the deployment. Let's look at what we need to do. So we need to send some ETH to that from account. Okay, so now we've funded the account because that's where it's going to come from. Since we use this, this sort of, it's like a signatureless. It's like a private key. It's like a private key that no one can ever know, right? We've crafted this transaction specific so no one can ever know what the private key is. So this is kind of like a one-time use thing. So we have sent money. So now that's where it's going to land if we run this transaction. And to run the transaction, there's a deploy script in here. So you just do node deploy and you paste in that transaction. You can see the 4 cows there at the end and go. There it goes. So that contract actually now lives at this address. So to prove that it worked, we're going to First, give it a block number of 0. This is just Clevis stuff. And then we're going to echo the contract address to just also some Clevis housekeeping, just to let Clevis know where the contracts are, so then we can run this command here, which outputs all the events. And we should see, there we go, there is one event, and that is what is triggered here. So we emit the TX origin, the message data, the message signature, and that's all this stuff here. So we can see that that argument did get in there. There we go. That's basically, we were able to, using this this 40-line script here, we were able to know what the address of the contract would be, and also it's signed and you can verify it. Like, you could send someone this piece here and they would not have the signature, so they would not be able to mess with it, but they could tell from this data right here that, like, this specific contract with these specific arguments is going to go to the chain if you make this call. So that's predictive deployment. You can get the address ahead of time. You have to fund the from address, but there's a lot of powerful stuff you can do with this counterfactual instantiation. So we'll use that later, but that's the first part. Cool, thanks.